Beverly Ibarola, Director of Marketing at Award Solutions. We're grateful to have you on today. For those new to Award, thanks for trying us out. For those that know us, welcome back. We're excited to have you all here. I just have a couple slides to share before we kick things off. This webinar is brought to you by Award Solutions. Award works with the world's best networks, and we serve a variety of clients across the ecosystem. We are also the training partner to organizations like GSMA and CCA. We're passionate about learning and helping our clients improve their skill sets. So whether on demand or live, our webinars let you experience our training in bite-sized fashion. This webinar is actually a part of a free learning series designed for those in cable that also included sessions on CBRS and AI for video. I have those links and can share those later if you like for the on-demand viewing of those. Because we develop and deliver free webinars on a variety of topics regularly, we do ask a small favor from those that attend. If you enjoy this session, we ask your help in sharing these learning opportunities with others. If you know someone that's interested in these topics, maybe someone out of work or someone needing a change, please stay connected with us and consider, sharing our emails and our posts on LinkedIn to help spread the message. We've had the opportunity to make a tremendous impact on others, improving knowledge and skill sets across the globe. Award has trained over 100,000 people on LTE, close to 20,000 on 5G, over 25,000 on virtualization technologies. We also have data-driven courses on topics like automation with Python, data visualization and machine learning. We offer courses as low as $39, and at the end of this session, we'll provide a coupon code that you can use for an additional 20% off. And go ahead and advance to the next slide. Just a quick note, we do plan to record this session. It usually takes a day or two before we get the emails out, but we will send you the slide deck and the link to the recording online, so please be on the lookout for that. And I am very pleased to introduce my colleague, Chris Reece. Chris is the technologist at Award Solutions. He is our go-to guy for researching and delivering content on cutting-edge technologies, and he's been featured across the globe at leading operators, at industry events. Lately, he's been involved with machine learning and AI initiatives for us. He's expert grade. He carries an extremely busy schedule at Award, and I'm so grateful for his time and efforts in delivering this complimentary webinar today. I know you're going to enjoy it, and with that, I give it over to Chris.
Thank you very much, Beverly.
Sure, thank you.
One last housekeeping thing before I get started. At any point during the webinar, if you do have questions, please feel free to jump into the chat and ask them. And I want to deal with questions as we go along. We have allocated some time towards the end of the webinar for Q&A, but don't let that hold you up. My plan for the next 55 minutes is really threefold. The first thing I want to talk about is a little bit on what is cloud native. What does cloud native mean? It's a term that's used very heavily within the industry today. It's a term that's been around for a little while. But both within the telecommunications industry as well as in the cable industry, it's being developed and deployed as we speak as a huge savings on infrastructure costs and speed to deploy things in the network. We're then going to focus in on a very specific aspect of cable that is part of the advancement of DOCSIS. It's part of the 10G initiative of cable, and it's called Distributed Access Architecture, or DAA for short. And so we'll do a quick overview of what is DAA and what are some of the challenges with DAA. And then really the heart of what I want us to focus on today is how do we take these two concepts and marry them to provide a virtualized infrastructure? How can we take the best from the cloud native world and the best from this distributed architecture, access architecture, and bring them together? Let's go ahead and get started with a focus on what is cloud native. Now, cloud native is a big, big topic. But let's start with probably the most fundamental piece of cloud native, which is what is virtualization? And I'm going to look at virtualization in 3 key steps. The first step of virtualization is what I'll refer to as pre-virtualization. With pre-virtualization, what we have is the ability to, or we had prior to virtualization at all. In pre-virtualization, this is where you bought a piece of hardware for the specific point of deploying that hardware for one service. And so back in these days, if I wanted to deploy an email server, I bought a piece of hardware and I put my email server software. I want a media server, I bought a piece of hardware and I deployed my media server. And what that meant was I had a lot of hardware that was underutilized. We go to around 10 years ago or so, we started to see more of a proliferation of virtual machines. Now, what a virtual machine is trying to do is it's really trying to take that host operating system and whatever the application is, and basically convert that into a self-contained piece of software. And this is referred to as that virtual machine. And the key part of this isn't really the virtual part, it's the machine part. It still thinks it's a standalone computer. And so it has its own full-fledged operating system that does everything. It has whatever the application is. But from an operator standpoint, from an IT enterprise standpoint, the benefit is I can deploy a piece of software called a hypervisor that allows for sharing. So now I have a piece of hardware that can actually be my email server, my media server, and a file server. And each of those still think they're individual pieces of hardware. So virtualization is great. Virtualization is fantastic with respect to isolation. We were able to very rapidly deploy things with virtual machines because we could take literally our existing infrastructure and port it into a virtual machine. And that's what a lot of people did. But there's one significant problem to this. And that significant problem is there's a lot of overhead. The biggest place that we're going to see that overhead is you'll see that we have all of these operating systems here. So when I say operating system, we're thinking Linux, we're thinking Windows, we're thinking something that's very heavy and does a lot of work. Do I really want to have that heaviness repeated? Well, my operating system, every piece of software needs an operating system to run. So if I'm going to deploy Firefox as a browser, well, I still need Windows or Linux so that it can interact with that operating system to actually do something. So I need an operating system in some form. But what would be really nice is if I could take this application and instead of running it in this guest operating system inside of this hypervisor, inside of this host operating system, is if I could kind of move it and have it running in a host operating system directly. So in other words, I kind of want to keep the isolation, but take away the overhead. And that leads us to the topic that we really want to talk about today, of containers. Now, I'm going to use the term container repeatedly. And when I use the term container, I really mean a software container. That's the more formal term. A software container is a container that packages some application as well as all of the needed dependencies so that it can be deployed in a system. Okay, so we're trying to have isolation and still an ease of deployment. So the first thing when we talk about cloud native, what we're really talking about is moving to the right on this chart. We're wanting to get to where we have more things that are in this containerized world. So what is a software container? Well, a software container, as we've already defined, is a piece of software. Think of it as a code that's doing something. But what we're trying to do is we're trying to encapsulate it in a way so that it is portable. It's self-contained. Fairly lightweight. And what I mean by lightweight is as little overhead as possible. I don't want to put any extra libraries, any extra binaries, any extra software inside of that container that's not needed, because all that's going to do is slow it down. And you've had that, right? You bought a computer and it had an operating system built in, and that operating system had a bunch of extra stuff that you didn't need. What did that extra stuff do? Slow it down. So containers are trying to take that mentality and say, hey, let's just streamline these to what we need. So a question came up from Joe. Sorry to ask what may be an obvious question. No, there are no obvious questions. All questions are good questions, but just wanted to make sure I understand. Can a virtualized non-container solution be called cloud native? And that is actually a great question, and the answer is no. Let me give you a better definition in a couple of slides, Joe, of what cloud native really means. But really the first thing when we talk about cloud native is it's something designed to be run on a cloud. And if you get nothing else out of our time together today, that's critically important. It's something designed to be run on a cloud. By definition, if it's designed to be run on a cloud, it can't be something that is, going back to this slide for a second, I'll never have anything here that's cloud native on the left. It always is going to have to be in some type of packaging. Can it be, does it have to be containerized? Technically, no, but in practice, what most people define as cloud native is in containers. Something that was designed assuming there's a cloud infrastructure. So it's a fantastic question, Joe. And if you have a follow-up question, please feel free to throw that into the chat. So that's really what a software container is. It's trying to have that isolation. Now, there's a term that you've probably heard about with respect to software containers, and that's called Docker. And we'll get to Docker in a second. But what Docker is trying to do is it's trying to ease the deployment of these containers. So you can think of Docker as really being the engine and the container being the thing that I'm trying to deploy. So what are the motivations for containers? Well, we really have three different categories of motivation. We have a technical, a programmer, and a software deployment. Now, this is really important, and a lot of times people confuse. And I'm going to kind of draw a line here because there's really two dominant use cases for software containers. There's what I refer to as more of the isolation use case and more of the deployment use case. What we're talking about primarily is we're talking about more of the isolation. I'm not saying the deployment side is not important, but I am saying there's some benefits that we don't really see. It's not really designed for what we're trying to do. So when I talk about isolation, what I'm really saying is I want to be able to get this hardware efficiency, right? So if I'm an operator, be it a cable operator, a telecom operator, I have a set of equipment. I want to maximize my investment. I don't want my equipment sitting partially idle. I want to be able to deploy things very quickly. So as I have new services come up, as I have new needs, as I have higher capacity demands, I'll deploy those things. From a deployment standpoint, maybe I'm a programmer and I want to make sure I have a constant environment for my software. It'll allow me to provide less technical support. And then another thing that we are going to discuss a little bit is maybe I want to take a service and deploy it as microservices. How can I take some big thing and break it into smaller chunks? Now, from a deployment side, this is the analogy that I like. How many times have you ever tried to deploy a piece of software and then realized that you didn't have the right dependencies? Especially if you're doing open source things. I can't tell you the number of times I've deployed something, I go to run it and it doesn't run, and I start looking at log files and it says, oh, you've got library 2.7.3. I only use library 2.4.9. Okay, so now what do? Do I downgrade the library? Do I try to fix the code? How do I move forward? With this deployment aspect, what we're really trying to do is create a package that has my application and any needed binaries or libraries so that they all can be together. So I don't have to worry as much about, is version 4.7.2 on this server or not? Isolation, ease of deployment. Those are the big motivations for containers. Okay, so what are some of the pros and cons of containers? Well, we've already talked a bit about the technical advantage. And if you want probably the best example of someone who uses containers on a daily basis, there's no better place to look than Google. Every time you go into a Google search engine, you're spinning up a container, it's running the search algorithm based off of your keywords, and it's providing you the results. And then it's dying. The container has a very short lifespan. So another thing when you think about containers, think about it as an application that's running, not as a machine that's running. So my computer may be running even though I'm not doing anything with it. A container is actively doing something. Now, if it's a web server, it's actively listening so that if someone has a request, but there's something that it's doing. We've seen already the developer value. It's also much easier to do software distribution. As a matter of fact, if you had your computer set up to support containers, you've installed some software to support containers, I could send you 2 commands and you could have something up and running that would be very powerful. It would pull a container from some type of internet repository and it would run it. Cons. Well, there is one negative to containers, and I think it's valuable that we talk about it, and that is security. Let me kind of back up a slide. I want to show you one thing real quick. Let's say I'm a bad guy and I create some bad code, and I'm trying to influence you to deploy the bad code on your system. And so here's my bad application. We'll make my bad application red. So I've got my bad application running. It's going to interface with this guest operating system. The guest operating system will then go through this hypervisor to go to the host operating system to get to the hardware. So really, what's vulnerable to any type of security attack? Well, that, which is already in isolation. It doesn't have any of the keys to the kingdom. It doesn't have anything of any value. When I go to a container, on the other hand, and I have my bad application, you can see it's running within this host operating system. Now, I only say that not as a threat or not as a real warning. I say that as just an awareness. It is a fact. Every release, people are doing better jobs of putting more and more security into these container engines. But it's software, and is it perfect? So I'll use a term of fencing, and that's what I really want you to think about. Think about a fence when you're thinking about this isolation. And when my kids were little, I had a little gates that I put around our living room so that the child couldn't just go to areas that they weren't supposed to go to and hurt themselves. But if the gate wasn't installed properly or if it wasn't closed, the kid could still get out. That's kind of what I want you to think about. It's like that gate. Is it effective? Yes. Is it perfect? No. So now let's transition to talk a little bit more about Joe's question, which is about cloud native itself. The goal is to design applications to be cloud native. Design an application with the expectation that it's running on a cloud. So that means we need a little bit more abstraction. It will allow it to be faster and easier deployed. We want to make sure that it's not too dependent on the infrastructure, because the more dependent on the infrastructure it is, the less likely it'll work. Think about applications that run on Windows but not Mac OS. They're dependent on the infrastructure. Something that runs on Ubuntu but not on Red Hat Linux. It's dependent on the infrastructure. I want to be able to enable something called DevOps. And really what I want you to think about with DevOps is moving away from slow interim releases of software to something that's more of a rapid release. The Facebooks and the LinkedIns of the world, Amazon, they deploy new software multiple times a day. When I worked at Nortel Networks back in the 90s, we went from a 2-year development cycle to a 18-month development cycle, and we thought we were just outrageous, right? I mean, come on, you couldn't go any faster than that. Now we're trying to have development cycles that are on the order of weeks, if not days, if not smaller. These are a good fit for things called service-based architectures. And what service-based architectures are all about is, can I have a service that kind of registers its capability so that other services can utilize it? For those of you that are in the telecom space, this is one of the designing principles behind the 5G core network. So one of the reasons the 5G core network is looking to be cloud native is because they've designed the infrastructure, they've designed the standard to be cloud native friendly. But there are still some challenges with respect to multi-cloud deployment. Am I going to deploy this on a private cloud? Am I going to deploy it on Amazon, Azure, Google, what have you? Now I want to talk a little bit about 2 key pieces of technology. And really what I want you to take away from the next few slides is what the technology name is and what really the problem it's trying to solve. And whenever you talk about cloud native, these 2 pieces of technology are always going to come up. The first is Docker. And what Docker is it is a container runtime engine. Its job is to help me in deploying containers. So you can kind of think of it in the same vein as some type of an application manager. You know, so if you've got some type of I even think of the simple, you know, looking in the taskbar of your searching on your Windows machine to launch something, right? So it's really kind of managing the launching of software. It is the most popular system today. As we've said, it's enabling application creation and deployment. It is open source, and it allows us to manage these containers. And it allows for something called a bare metal deployment. What a bare metal deployment means is I'm not using a virtual machine. I don't have to use a virtual machine in this. So this is the main architecture of Docker. So this thing that says a Docker host, what I want you to think of this Docker host is this is a server. On that server, you're going to have a host operating system, probably going to be Linux based. probably either Ubuntu or Red Hat Linux. It could be Windows, could be a Windows Server platform. You've got the actual runtime engine, and what the runtime engine does is it works with the operating system to launch containers. And then on top of that, it will work with some type of a repo so that it can actually have a place to store those containers. Now, the key thing I want you to see in this picture is this is one server. But as an operator, even as an IT manager, what's the likelihood you're going to have one server? Pretty small. You're probably going to have many servers, tens, hundreds, thousands, tens of thousands of servers. So now if I have a container that I need to launch, I have to decide which one of my 10,000 servers do I want to launch it on. That could be problematic. And that really is the lead into our next topic. So Docker is on a per server basis. Kubernetes is a container orchestrator. And what a container orchestrator is doing is exactly what I kind of alluded to. It's trying to decide which one of those servers to deploy a specific container. So you don't go and say, as a human being, I want to deploy a container on server 42. You say, hey, Kubernetes, I want to deploy this container. And it goes and decides which server it is. And on top of that, if that server has a problem, it changes. It moves the container or spins up a new version of that on a new server. So it's managing that deployment across all of these different platforms. It as well as open source. It supports many cloud and bare metal environments. We've already talked about scheduling across multiple nodes. It can also manage my scaling. So it can be configured to say, okay, when that container gets busy, I'm going to add another copy of it. It can do self-healing. And the way it does self-healing is it says, that container isn't behaving. That container isn't doing what it's supposed to do. I'm going to kill it and make a new one. That container failed. I'm going to spawn up a new one automatically. The self-healing is huge. The self-healing is huge. I can do load balancing, as well as when we have updates, instead of just trying to update everything at once, we can do rolling updates and kind of update 2 of them at a time until we've gotten everything updated, for example. So what Kubernetes is going to do is it's going to create a couple of nodes that it refers to as master nodes or controller nodes. And then it has some nodes that are referred to as worker nodes. Now, those servers that we had on the other page, on the Docker page, that I just said server, this is really where Docker is running. So what this master node is going to do is it's going to say, I want to deploy this container, and it'll decide which one of those nodes to deploy it on. Another term I have here is a network function. So if we're looking at this from a network functions virtualization standpoint in NFV, then this is that software that we're wanting to deploy as that network function. So a great question on the chat. Manish is asking, what exactly is a cluster in Kubernetes? And he actually is using the short version. So the short version, which I haven't talked about, is to say K8S. If you don't want to type out Kubernetes, and where this comes from, it's actually kind of funny, is they keep the K, they keep the S, and there's 8 letters in between. And so that's why they shorten it to K8S. A Kubernetes cluster is a one or more master nodes and some number of worker nodes together. So you can think of a Kubernetes cluster as the master nodes and all of the worker nodes that it's managing. How many worker nodes is that? It depends on your deployment. I'm working on a project right now where they're using Kubernetes, and they're using Kubernetes to manage a control plane function. And so there's only 3 or 4 nodes in the entire cluster because that's what they need for that particular deployment. I've worked on other systems where it's much larger than that. But that's what a Kubernetes cluster is, Manish. It's just the work or the manager node, the master node, and all of the worker nodes. So any deployment of Kubernetes can be called a cluster. Yes, it can. And so you could even use, if you want to play with Kubernetes a little bit, there is a kind of a toy version of it called Minikube. Let me put it in the chat, Minikube. And what Minikube is just the ability to deploy Kubernetes on a single server. And so in some of our Kubernetes classes that we teach, what we do is we give a lab to each student that has Minikube on it. And so now they can run all of the Kubernetes commands, and they can make whatever changes they want. They're an admin, and everything is cool without having to worry about things like, are they going to mess up something for somebody else? So yes, and so that is technically a cluster as well, even though it's one master node and one worker node really all built together. Jose has another question. So as a service provider, when we think of cloud native, is it correct to think that the choice of whether to partner with AWS, Google Cloud, Azure, et cetera, or build your own is essentially deciding how to bring Docker and Kubernetes into our architecture? Absolutely. So Joe, you're really asking 2 great questions. One, I don't have to own that cloud native architecture, just as you're saying. I could partner with AWS, Google, Azure, Cloud 28 in Europe, whoever. Or I could build my own. And so really the thing when you think about cloud native, I want you to think about is how can I start thinking about the services I deploy as being able to be deployed in a containerized fashion. And where I deploy it is kind of academic. Let me give you, here in the United States, this is probably the best example, which is, let's say that I wanted to deploy many different services for my clients. Well, if they're doing basic web surfing, it's a web server or it's a media server, maybe I'm going to deploy that in a public cloud like Azure or Amazon or whatever. But what if I'm dealing with things like health records? What if I'm dealing with things that are of top secret security? Then I might build a cloud that meets all of those requirements and deploy those things there. Excellent. And one last term I want to throw in there, and this isn't directly related to cloud native, but it's actually being used within the cloud native space, is something called network functions virtualization. And what network function virtualization is it's an architecture that was originally designed by ETSI, the European Telecommunications Standard Institute, for the sake of virtualizing services and deploying them. So what we've really been talking about is we've been talking about this. This could be Kubernetes. This virtualization layer could be Docker. And these could be our containerized network functions. So that's a little bit, one more slide, and then I'll do my summary. I know this is not going to be visible. This is it's called the Cloud Native Computing Foundation Landscape. And so within the Linux Foundation, there's an organization called the Cloud Native Computing Foundation, CNCF. They are tracking every project associated to cloud native. And you can see this is, and this, they're always updating this map. So at the time of this webinar, this may be out of date because they may have changed it yesterday. So you can go to l.cncf.io to learn more about their landscape. But what I like about this, and the reason I wanted to show this to you, is I want you to see how many projects are associated with this. There's a ton of work that's being done in this space right now. So if you're looking at deploying a cloud native cloud, you could deploy it yourself, or you could partner with a number of these different companies that are here to actually bring it to life. And so there's a lot of stuff going on there. And so kind of to go back to the question that Joe asked, right here in the middle, these are certified Kubernetes hosted services. And you can see AWS is right there. So what this is really focusing on, there's others in here, but what this is focusing on is exactly what Joe was saying, is I don't have to deploy this myself. I could use somebody else's. Okay, so that was a little bit on cloud native. Questions, comments, thoughts with respect to cloud native? Excellent. Now, there's many ways that we could take the conversation at this point. And this is just barely scratching the surface. Like I said, I hope you get a couple of terms. But what I want you to see is a very concrete example. And I want to focus on the cable space for the next 20 minutes. And one of the big pushes within the cable space is something called a distributed access architecture. And the purpose of the distributed access architecture is to help us go to higher and higher speeds for our internet connections at our home. So to start, before we get into the distributed access architecture, I want to focus on the centralized access architecture. What the centralized access architecture is, this is the older way in which things were being done. So what we would do is we would put most of our active components into some type of a hub site or something that's used within the cable industry, something called in the cable industry called a head end, HE for short. Then what we would typically do is we would use some type of fiber optic connection to connect us to remote sites. Then what those remote sites would do is it would convert from this analog optical connection into a coaxial connection, which was where we would connect to the cable modem in someone's home, and then that would give me the internet connection into my house. So what are some of the limiting factors to the data speed that I have? Well, one limiting factor is going to be based off of distance. When I use a coaxial cable, it is an electrical transmission versus an optical transmission. Electrical transmissions, just because of physics, can't travel as far. So one of the goals is for me to continue to move these remote units closer and closer and closer to the subscribers. Well, as I move the remote units closer and closer to the subscribers, I need to have a way of better sharing these optical connections. Whenever you use analog, pretty much, I want you to think, not real easy to share. If I could do something in more of a digital domain, then I have the opportunity to do some more advanced things. And all of my control is here in this hub or head end. So what I'd like to do, not only my control, my generation of the signal, right? Since everything is analog, I'm generating the signal here within this head end. So what I would really like to see is I'd really like to see a way of pushing some of these components closer and closer to the subscribers. Now, if you come from the telecommunications side, if you come from the wireless side, and from everything I've described, you're probably thinking, wow, this sounds a lot like what we call in telecom of O-RAN, or cloud, making a cloud version of our radio access network, that distributing the control from the physical antenna in the cell site. And you're absolutely right. There's a lot of similarities here, and a lot of the challenges are the same. Now, the architecture is different, but the concepts and the problem of physics is the same. So what Cable Labs has done is they have enhanced their specification, DOCSIS, to include a distribution of this, and that's referred to as a distributed access architecture, or DAA. And there's two key elements that I want you to think about when you think of DAA. The first element I want you to think about is we're moving an active component from this head end or hub into the remote sites. And so now, instead of using that analog fiber for the connectivity, we're going to move to a digital fiber using a standard called PON, a packet optical network. The second thing I want you to see is that we're actually moving our generation of the signal here so that I have a shorter distance on this coaxial cable. So I'm shortening my distance here. So the shorter that distance, the higher the bandwidth can be. And that's really kind of the big piece of this distributed access architecture. It's really trying to pull some of the elements out of the hub and move that into a remote system. Now, there's three basic flavors of this this distributed access network. There's something called a Remote PHY, or RPHY. And what this is trying to do is saying we're going to keep most of the control in the head end and just do the physical generation of the signal in the remote site. There's something called a remote CCAP or CMTS, and this is really taking the MAC and the physical layer and putting it into the remote system. And so it's some of the control as well as the physical layer. And then lastly, we have a remote CMC, which is a partial split of that MAC layer. Now, all of these are providing a similar benefit, and I don't really want to think about a compare and contrast of these different options. What I'm wanting you to see is just that we're trying to do that split and move an active component to being into a more remote location. So to kind of summarize this, and this is from an article that CableFax has put together, is what are some of the benefits and challenges of DAA? Let's do benefits first. Benefits are more fun. Reduce space and power savings. Okay, so the more I'm able to move things out, I can make those head ends, those hubs, smaller and smaller. As we've already said, moving PHY closer to the home results in better network performance. This is hopefully going to lower our operational expenses. Now, I understand we are going to have to go through a capital investment to get this set up. So don't think my overall expenditure drops in 2021. Think, as I look at the cost of managing my network over time, it will decrease. And this allows us, and this is really the whole purpose of this webinar, is this bullet here, is it allows us the ability to provide a path towards virtualization, which we'll get to in a second. Challenges. It's increasing the complexity. If you compare what we've had in previous generations of cable modems, they were much simpler systems. And every time we want to go to higher efficiency, the cost is always going to be complexity. And that's really with anything. I have yet to see a system that became less complex and more efficient. Usually it's more complex and more efficient. I have more interoperability testing because I could have different vendors. Because things are farther away, I have timing and synchronization issues. I have to do more software and maintenance across a wider environment. And because so many of those active components are remote, I now might have to do more maintenance of those components. If it's passive components that are remote, they don't break as often. Active components have higher probabilities of breaking. So let's take the two topics that we've talked about so far and let's bring them together. How do we start to think about virtualizing this distributed access architecture? Well, first, before we even look at that, let's look at this from the perspective of edge computing. Now, edge computing is a term that has been popped up for a number of years. And what edge computing is really trying to do is it's trying to, instead of focusing on having really big hyperscale data centers, and I want you to think Google and Azure and Amazon, or centralized clouds. This may be a centralized private cloud someplace. I want us to start thinking about having some type of access sites, some type of remote sites that has a few number of servers in it. Now, the reason for this is now what I have the opportunity to do is to say, I want to deploy a service. Now, maybe that service would be very good to deploy out here in this public cloud. Maybe the service would be very good to be deployed in a private cloud. Maybe because of the nature of the service, I need to deploy it much closer to the users so that I can have the appropriate delay, throughput, or whatever is needed. And so that's really what edge computing is all about. Now, there's a term that's also used, it's used within the telecom and the cable industry that's called MEC. And what MEC stands for is multi-access edge computing. And it's an architecture that was originally designed, or it's been standardized by ETSI. And the purpose of that is so that we can have these servers out here remote and have the ability to, just as we've said, deploy software where it's needed. One other thing I want you to see on this chart is notice how the delay drops as I get closer. This is due to physics. This is just distance. This is nothing more sophisticated than that. If I wanted to access a web page from Dallas, Texas, where I'm located, to Sydney, Australia, there will be a delay of at least some amount because Sydney, Australia is on the other side of the world from me. It doesn't matter. It doesn't matter how good the servers are. It doesn't matter what my internet connection speed is. It doesn't matter what kind of computer I have. The distance the light has to travel will be the determining factor on the delay. In comparison, if I were to set up a web page in a web server in my son's room right next door, in the bedroom right next to me, it would take hardly any time at all because it's just a few feet away. So here's the question. I'd love to get your input. Feel free to jump onto the chat. So now that we talked a little bit about virtualization and we've talked a little bit about DAA, what are good candidates or things in your mind to virtualize? Now, let me give you one caveat to that. When it gets to the physics itself, the actual generating of a signal, that will be a hardware component. But what are some things that we might want to virtualize? What are some things that we would want to convert from being a dedicated appliance, a box I buy and deploy, to something that's more software on some type of a shared computer, an Intel or an ARM-based server. Now, Manish has jumped into the chat and has said an RU or a DU, a remote unit or a distributed unit. And that's a great answer. And so what I might do is I might have, especially here in this PHY category, is I might virtualize that function. And in virtualizing that, that will give me some benefits. So I have these servers here now. So that's a great answer. And kind of the flip side of what Manish is saying is there's also elements here that I might be able to virtualize. Maybe it's the CCAP, this cable application hardware. Maybe I can virtualize that. Maybe I can virtualize these controllers. Maybe, depending on the amount of throughput, I might even be able to virtualize some of these routers. So here's kind of my summary, the way I kind of think through this. So if I wanted to go through and create a cloud native system for DAA, in my mind, I'm going to have two different types of clouds. I'm going to have a more centralized cloud, and that will use something like Docker or Kubernetes. Cable Labs has put together something called Project Adrenaline. And what Project Adrenaline is trying to do is to try to help speed up the deployment of services onto a containerized platform. So maybe I'm going to use something like Project Adrenaline. Maybe I'm going to utilize some of the network functions virtualization parts that have been defined by ETSI. Something called orchestration, something called a containerized network function or a virtualized network function. But what I would do is I would deploy this cloud, and then I would have to virtualize some of these components that I would think need to be virtualized. Or more importantly, probably work with a vendor who's already virtualized these. The more interesting part in my mind is down here. I need to deploy some type of an edge cloud. And in the edge cloud, I'm still going to use things like Docker and Kubernetes. As a matter of fact, I may use the Kubernetes from up here to push a container down here. Again, Project Adrenaline is valid. We talked a little bit about that multi-access edge computing. So maybe I'm going to virtualize some of these components and then have them managed by this centralized Kubernetes pushed to the appropriate edge cloud to support service for people in that area. How many edge clouds do I have? Hundreds, thousands of them. Just really depends on how I want to set up my network. So really the thing I hope you take away from this discussion is twofold. One, what is cloud native? What's the power of cloud native? And let me tell you, Kubernetes is, the more I learn about it, the more impressed I am. It is super valuable. There are people that are redesigning the architecture of their products because of what Kubernetes provides. So instead of them needing to deploy a whole bunch of stuff that they had to manage and build themselves, ripped all that out, Kubernetes does it instead. It's amazing how powerful Kubernetes is. So once I have figured out how to deploy my software, then I have to figure out where to deploy my software. How do I need to build these individual clouds? Are there any questions before we wrap things up? We're getting close to the top of the hour. And Beverly did push out onto the chat the 2 links to previous webinars. One of them, one of my colleagues did on CBRS, which is a spectrum sharing technology that's being looked at for trying to do wireless when you don't have as much spectrum for everybody to have their own dedicated spectrum. And then second was a webinar that I did on AI and AI use cases for video. And so I've got a request for my email. I'll put that into the chat. As Beverly mentioned when we were starting, if you would like to take a technology primer or self-paced e-learning, here is the coupon code. The coupon code is webinar, or you can use the QR link. And you can get an additional 20% discount on that. Question. Joe is asking, so can you share at a high level more about an architecture with multiple clouds? Is there a master cloud to control all clouds? So in essence, Joe, you're right. That's exactly it. What you would do is so say I've got, here's my private cloud, and here's my Kubernetes managing that private cloud. Then what I would have is I would have, say, Azure AWS. So when a human being comes in to say, I want to deploy a container, we could look at the characteristics of that container. I could even go a step further and say, here's one of these edges. And what it can do is it could deploy it to one of the individual servers that are local, or it could work with a Kubernetes that's here, or here, or it could deploy it to a server here. So it's really much more configuration. And so don't think of this as a master in the sense of it is over these other Kubernetes. Think of it as more of an interoperation. So I can pass this off to somebody else. I can get another Kubernetes to take over management of it. Great question. And yes, Manish, we will be sending out an email. Give us a few days, but you'll get an email that will have a link to the video as well as to the slides that I presented. We're always posting stuff on our different social media platforms, as Beverly mentioned early on. If you want to follow us on LinkedIn, use the QR code on the left. If you would like to connect with me, feel free to use the QR code on the right. That's my LinkedIn profile. And if you have further questions, please feel free to reach out to us. Either reach out to us on, to me personally on my LinkedIn or onto the Award Solutions LinkedIn. Are there e-learning courses on Kubernetes and container particularly? Yeah, we have one on, I believe I'd have to double check that we have we have tech primers on Kubernetes for sure. I'd have to check, Beverly. I don't remember off the top of my head if we have an e-learning on that. I think we do. I want to thank you guys so much for attending today. I do appreciate you taking time out of your busy schedule. I'm going to hang around for a couple of minutes if anybody does have questions. Otherwise, thank you so much. Go on with the rest of your day. Stay safe. Let me know if there's something that we at Award Solutions can do to help you out.